Good morning again, everyone. Welcome to another episode of Physics in the Garden. Today I'm going to look at Hooke's law. Now, you'll have seen various videos probably about Hooke's law, but I'm not going to make a boring one like you might have seen before with springs and stuff and anything like being indoors. I'm going to today find out if we can test for whether a pair of old tights has or obeys Hooke's law. So to do this yourselves, you're going to need a few bits and bobs of equipment. The equipment you're going to need is some tin cans, various sizes could be used, a tape measure, and a pair of old tights. And then just somewhere to record your results. Now, hopefully you can remember for Hooke's law that what it says is that anything that obeys Hooke's law, if you apply a force, the extension of the object the force applied to will be proportional to the force applied. So it doesn't matter that the cans I'm going to use are actually not all the same size, because I can just work out the force that each one's applying and see if that extends it by a proportional amount by drawing a graph, which we'll see later. So the first thing that I've done is I've just set the equipment up. So I've got my old tights hung next to measuring tape, and I can read off what the starting position is there, and I can see that it's 67 centimeters. So everything else from there is going to be an extension, and I can see how much it extends from 67. Okay, so I'm just going to put the first weight in, which I'm using this can of John West tuna chunks, and we'll see how much that extends the tights to. I can read it off, and it is 97 centimeters, which is an extension of 30 centimeters. So for the next few, I'm going to keep adding weights, but I'm just going to speed up the video so it's not too boring. Now you can see that it's stretched quite considerably. We'll find out when we look at the results later on, which I've recorded on here, what whether or not it's followed Hooke's law. Now you can see I've recorded the number of cans, but obviously what we need to do now is convert that into mass. So to do that we need to know the mass of each of the types of can, and then I can calculate the total mass for each extension. Okay, so the mass for the tuna is 191 grams. Write that up there. Okay, and then the mass for the soup, 400 and can't decide. It seems like the soup's getting heavier and heavier. 454 grams for the soup. So I'm just going to write that on there as well. I'll do the calculations to work out the mass of each extension. So they're the final results, which just now need converting to kilograms and then into newtons, because of course it's the force applied, although it is proportional to mass because we did every single one on Earth where gravity is consistent. But I will just convert them into newtons and then plot a graph, and we'll see if we get a straight line it obeys Hooke's law, if not it doesn't. So you can see I've converted the mass into kilograms and then multiplied by 9.81 to get a force, and then graph this against extension, and as you can see from the graph it's definitely not a straight line, and therefore it doesn't obey Hooke's law. We can actually see from looking at the tights, if you look at the bottom, that the leg that I put the cans in has stretched, so it has obviously gone beyond its elastic limit, which kind of bears out what we were saying about Hooke's law. So I hope you enjoyed today's Physics in the Garden, and it's giving you a bit of a better insight into the elasticity of a pair of tights.